Serverless computing has fundamentally changed how applications handle traffic at scale. A function that serves 10 requests today can serve 10 million tomorrow without any infrastructure changes. This video explains precisely how that happens, from the moment a request arrives to the point when thousands of function instances are running in parallel. Traditional web servers operate on a fixed capacity model. You provision a number of machines, configure them to accept connections, and hope the incoming traffic never exceeds what you have planned for. When traffic spikes suddenly, during product launches, viral events, or scheduled batch jobs, that fixed capacity becomes a hard ceiling. Provisioning new instances takes minutes, not milliseconds. In the serverless model, the platform takes full responsibility for instantiation. Each incoming event, an HTTP request, a queue message, a file upload, triggers exactly one function invocation. The runtime provisions a container, loads the function code, and executes it. There is no shared process pool waiting for work. Each invocation is fully isolated. When a new request arrives and no idle instance is available, the platform creates one. This is called a cold start. If 1,000 requests arrive simultaneously, the platform creates 1,000 instances simultaneously. The upper bound is not determined by pre-allocated hardware, but by the account's concurrency quota, a soft limit that can be raised on request. A cold start carries measurable overhead. The runtime must pull the container image, initialize the language runtime, and load your code before the first line of business logic executes. A warm start reuses an existing idle instance that already has the runtime loaded. Most platforms retain containers for several minutes after each invocation, ready to serve subsequent requests at near-zero dispatch latency. AWS Lambda supports up to 1,000 concurrent executions per region by default, with quota increases available into the hundreds of thousands. Provisioned concurrency can pre-warm a defined number of instances, eliminating cold starts for predictable traffic patterns. These numeric controls give engineering teams precise leverage over cost, latency, and throughput. Consider an e-commerce API during a flash sale. Traffic can increase by a factor of 50 in under 2 minutes. A traditional auto-scaling group would take 3 to 10 minutes to provision new instances, during which requests would be dropped or queued. A serverless deployment absorbs that spike within seconds by spawning parallel invocations entirely on demand. Serverless platforms expose 3 primary controls for scaling behavior. Reserved concurrency gives a function its own slice of the account's concurrency pool, preventing other functions from starving it. Provisioned concurrency pre-initializes instances to eliminate cold starts for latency-sensitive workloads. Memory allocation governs CPU proportionally. Doubling memory roughly doubles compute throughput. Edge function runtimes, Cloudflare workers, Lambda at edge, Versal edge functions, extend the serverless model to over 300 network locations worldwide. Functions execute in the data center nearest to each user, reducing round-trip latency to single-digit milliseconds. The same per-request instantiation model applies, now distributed globally by the provider's Anycast network. Serverless is not a deployment convenience. It is an architectural shift toward demand-matched compute. Functions scale because the platform's entire purpose is instantiation on demand. For applications with variable traffic, this translates to lower infrastructure costs, higher reliability under load, and engineering teams that focus on logic rather than capacity planning.